So these two equations have a common root. A common root does not mean that these equations have only one common root. They can have one or two common root as well. Okay. It just says a common root. Okay. It can be one common root or two common roots are also possible. So we'll first check with the condition of two common roots. That is pretty easy to check. 3 upon 6 will be equal to minus 2 upon minus 17 is equal to p upon 12. So 3 upon 6 is not equal to minus 2 upon minus 17. This is absurd. So this is not possible. Now we will start with the condition for one root common. Okay. And that would be 3 into 12, that is 36, minus p into 6 minus 6p whole square, which will be equal to 3 into minus 17, that is minus 51, minus minus 2 into 6, that would be plus 12. Okay. Into minus 2 into 12, that is minus 24, minus p into minus 17 would be minus 17p, that would be plus 17p. Okay. And I can take out 6 common from here, and square over 6 will make it 36 into 6 minus p whole square will be equal to minus 51 plus 12, that is minus 39 into 17p minus 24. Okay. Divide both sides by 3. This will be 12 and this will be minus 13. Now opening this bracket, this will be 6 square, that is 36 into 12 will be 432 minus 2 into a into b, that will be 12p, minus 12p into 12 will be minus 144p plus 12p square is equal to minus 13 into 17p will be minus 221p plus minus and minus plus 13 into 24 will be 312. Okay. And the final equation will be 12p square plus 77p plus 120 is equal to 0. And you know how to factorize this. This we have seen in solving quadratic equations, right? Solve this and get the value of p as minus 8 by 3 or minus 15 by 4. This will be the final answer. Next question. Find the value of p so that this equation and this equation have exactly one common root. Okay. So these equations have exactly one common root. So we'll directly apply the condition of one common root. We will get 1 into 3 minus p, 1 into 3 minus p minus p plus 2 into 1, p plus 2 into 1, this whole square is equal to 1 into 1 minus p, 1 into 1 minus p minus p into 1, p into 1 into this whole multiplied by p into 3 minus p, p into 3 minus p minus p plus 2 into 1 minus p, p plus 2 into 1 minus p. Lots of p are there. Let's simplify this. 3 minus 2 is 1 and minus p will be minus 2p whole square is equal to 1 minus p, that would be 1 minus 2p multiplied by 3p minus p square, 3p minus p square minus p square, minus and minus will become plus p square, and p minus 2p will be minus p, and minus will become again plus p plus 2, and this minus sign will make it minus 2. So this will be 1 minus 2p into 3p plus p will be 4p this gets cancelled, minus 2. So in short, 1 minus 2p whole square is equal to 2 times 1 minus 2p into 2p minus 1. Okay. If I take this whole to the left hand side, this will be 1 minus 2p whole square plus 2 into 1 minus 2p whole square is equal to 0. Basically, we have 3 into 1 minus 2p whole square is equal to 0, and that can only happen when 1 minus 2p whole square itself is equal to 0. Okay, from here we can say p is equal to 1 by 2. We have got the answer p as 1 by 2. Before marking this as the correct answer, I just want to put this value back again in these two equations that we have, this one and this one. So let's put the value of p as 1 by 2 in these equations. This first equation will become x square plus 1 by 2x plus 1 by 2 plus 2 is equal to 0. And this is nothing but 2x square plus x plus 5 is equal to 0. Okay. And p as 1 by 2 here will make this equation x square plus 1 by 2 x plus 3 minus 1 by 2 is nothing but 5 by 2. So this equation is also 2x square plus x plus 5 is equal to 0. Same, this is equation 1, this is equation 2, both the equations are same. Okay. So that simply means that both the roots are going to be common. And our question clearly states that these equations have exactly one root common. But the value of p that we have got after solving, the value of p as 1 by 2 is giving both the roots as common. So p equal to 1 by 2 is not the correct answer. Our answer will be A. No such value of p exists. Okay. So for questions which mention exactly one root common, for such questions, I want you to verify your answer once. If your answer is making both the roots common, then I want you to reject that answer. Okay. Next question. Okay, one root is common between these two equations and we have to find the value of a and b. So they have one root common. That means either one root is common or both the roots can also be common. Okay. Unless it clearly mentions that exactly one root is common, we are going to assume that either one root can be common or both the roots can also be common. Okay. One more thing that you have to notice here is that we have to find values of two variables. And condition for one root common only gives us one single equation from which it is impossible to find the values of two variables, right? Another thing that you have to notice here is that this equation has discriminant less than 0. B square minus 4ac is less than 0. That means roots are imaginary here. Okay. And if roots are imaginary, that means this equation and this equation have a imaginary root common. And if one root is imaginary, another root has to be imaginary because both the roots occur in conjugate pairs. That simply means that both the roots for these equations will be same only. If one root is p plus iota q and that is common, then the second root for both the equation will be p minus iota q only, right? Because imaginary roots occur in conjugate pairs. So both the roots for these equations will be common. And that is what we are going to apply here. Condition for both the roots common. That would be 1 upon 3 is equal to 3 upon a is equal to 5 upon b, right? We have compared the coefficients for both the equations. From here we can get the value of a as 9 and from here we can get the value of b as 15, right? So if two quadratic equations have one root in common and one quadratic has imaginary roots, then it should be obvious that both the roots are going to be common. Okay. Last but not the least, find the number of roots common between the two equations, these two equations. Let's say this first equation has a graph something like this and this second equation has a graph like this. At these points, the two equations are becoming equal. At these points, the two graphs are intersecting, right? The two equations are becoming equal. So if I simply equate these two equations, I am going to get these 3 points. Let's find these points first. X cube plus 3x square plus 4x plus 5 is equal to x cube plus 2x square plus 7x plus 3. X cube and x cube gets cancelled. X square minus 3x plus 2 is equal to 0. So I have to break this minus 3 into two numbers whose product is 2. That would be minus 2 and minus 1. So this will be factorized as x minus 2 and x minus 1 is equal to 0. X will be either 2 or 1. So these are the points of intersection. These will be the points where this cubic and the second cubic will intersect, these points. Now whether these points are roots of these cubic equations or not will be determined only by putting these values back into the equation. If these values of x make this cubic equation 0, then that would be a root of this cubic equation, right? So I'm going to check for each of these values. Putting back 2 in this first equation will be 8 plus 12 plus 8 plus 5 is equal to 0. This is not equal to 0. 2 is not a root of this equation. Okay. And this 1, is 1 a root of this equation? No, 1 will also not satisfy this equation. 1 is also not a root of this equation. So these were the common points. 2 and 1 were the common points between these two cubic equations. But these common points are not roots of these equations. So there are no common root for these two equations. Okay. Graphs for these two equations are not going to intersect. This is not possible. The graphs will be something like this. Okay. That's it for this video. I hope you liked it. I hope you got something out of it. All the concepts that were discussed in this video were clear to you. Thank you for watching.